speak at this webinar. So today we are diving into a fascinating topic, the satellite-based crop health monitoring system. So you might be wondering what exactly does that mean? Most people think of satellites as GPS technology used for tracking vehicles, but there's so much more to it. Imagine harnessing the power of satellites to keep a vigilant eye on your crops. So this advanced technology provides us with a wealth of data, offering detailed insights into crop health, irrigation needs, soil organic carbon levels, and much more. By leveraging this data, we can boost crop yields, minimize crop losses, and optimize irrigation and fertilization practices. Next, we will explore how Farmonaut is leveraging this technology. So in our platform, there are like multiple different parameters which are used to provide the insights to the farmers and organizations and startups and companies. So what does it mean by parameters? So parameters are the images or the indices which we use to provide health advisory, irrigation advisory, and so on. So we will see each and everything. I will not go in much of technicalities, but I will tell you what these are and how these are used. So for suppose a crop, there is a crop like maize or soya bean, which has a denser canopy. So we use NDR. So NDR is normalized difference red H index. So this is used when there is a crop which has a denser canopy and it has a good height. So this parameter provides the crop health data of that particular crop. So it will tell you about the location where exactly something is going wrong. So as we all know that prevention is better than cure. So if we know earlier that this particular area of or a patch of our farm is going bad, we will be able to provide some measures and use some measures to like stop it there and it will not harm the crop. So in those conditions, these health parameters are used. So as I mentioned, NDR is used for denser canopy height, canopy and a crop with a more height. Then NDVI parameter, normalized difference vegetation index. This is used for crops like wheat, paddy, when there is not such denser canopy. This also provides the same thing. This will let you know about the locations where crop health is declining. Then suppose we have trees like mango trees. So in the case of trees, there is a bit of gap between one tree and another tree. So in those conditions, if we use NDVI and NDRE, because there is a soil exposure between one tree and two tree, it won't be much effective and the data will not be that correct. So in that condition, we will use SAVI, soil adjusted vegetation index. So this is how this SAVI will be used and it will let you know about the health of the plantation. And so on, EVI and VARI. These are also the similar cases. Then moving on to the irrigation part. So we have seen like in many cases, in the farmers, they irrigate the farm, but they actually don't know which locations they need to irrigate more frequently or if that patch really requires that much frequent irrigation or not. So because of that, when if the field is less irrigated and it is more irrigated, then also it is harmful for the crop. It will be like very harmful because if the lesser the irrigation and more the irrigation, there are high chances of pest and disease might occur on that particular crop. So in that case, we need to understand which are the locations where irrigation needs to be done on a frequent basis and which are the locations we need not to do irrigation in such a frequent basis. So we have NDMI, NDWI, evapotranspiration, these three images. So NDMI is just the soil moisture. It tells you about the soil moisture of a particular field. NDWI will let you know about the water quantity in the plantation itself. And evapotranspiration will let you know how fastly water is evaporating from both the plantation as well as soil. So combining these three, you will get to know the patches where actually we require to irrigate. Because suppose there is a patch or a field where evapotranspiration rate is high. That means water is evaporating very fastly. So if you are doing irrigation on a normal basis, like not that frequently, so what will happen is you did the irrigation today, and within like few hours it got evaporated. So this the crop does not have that kind of moisture which it requires. So moisture is less in that. So in that condition, we need to irrigate in a faster manner. So that's how these irrigation parameters come into picture. Then coming on to the next one, the soil organic carbon. Soil organic carbon tells you about the organic carbon content present in the soil itself. It is a very vital for maintaining soil fertility health. High levels of soil organic carbon indicates good soil structure and nutrient availability, which is very essential for an optimal crop growth. And this also tells you that what might be the quantity of other nutrients in the soils, like NPK, zinc, sulfur. Because we have seen that the locations where soil organic carbon is declining, there are high chances other nutrients might also be declining. So if you know how the soil organic carbon is in your location, there is high chances other nutrients are also in good quantity. This helps farmers, like because we have seen farmers doing soil testing. What they do is they to take random samples from the soil. So what happens, sometimes they miss the patches where actually there is some issue in the nutrient quantity in that particular area. So instead of that, what we recommend is where the soil organic carbon is less, go to those locations, take the soil samples and take them for testing. So we recommend taking the soil samples from those locations where soil organic carbon is on the lesser side. You can take from other locations as well, but we prioritize this, that they can do this. And for areas where, like suppose there is a farm which has an unevenness, so in those cases, DEM helps. DEM is digital elevation model. It provides detailed information about the land surface, including the elevation. This is useful for understanding terrain, and it will help you in planning irrigation. So suppose there is a land where there is unevenness in the farm. Few patches are in high terrain, medium terrain, low terrain areas. So what will happen? Water logging will happen if you do the irrigation. So if you know in advance that these are the locations which are uneven, you can even them, or you can have some measures to take out the water when a water logging happens. So in this condition, in this way, DEM helps. So, and when it comes to satellites, so most of them will think that satellites will not work when there is a cloud cover, or a rainy season. So it's actually true. Most of the sensors won't be able to penetrate clouds. So in that condition, we have radar data. So what does radar data means? These are the sensors on the satellite which works on microwaves. So these particular sensors will be able to penetrate clouds. So those are known as RVI and RSM. So RVI is radar vegetation index and RSM is radar soil moisture. So these two provide the RVI provides the crop health information and RSM provides the soil moisture information. So even in the cases when there is cloud cover, when these other parameters like NDVI, NDMI are unable to give you the data, you still will get the RVI and RSM data. And this will be able to help you to plan your health and irrigation status while there is a cloud cover as well. So you won't be completely blind in those times. You will be able to get colored blind visualizations. So the on our platform, you will get an images which are in just black and white, because we received an query from a farmer who is colorblind. So he is unable to differentiate between colors, because in our platform, what we do is we do the color coding. So the more the green is the patch, that means the soil health or irrigation is in good condition, and more on the redder side, that means there's some issues. So a colorblind person is unable to differentiate between these colors. So what we did, we made a colorblind index as well, so they can just check the black and white patches. You can do the land classification as well using the satellite data. So what does land classification means? It will tell you in a certain geography how much land is under crop, how much land is under forest area, how much land is under civilization or factories or buildings are being there. So this is how you will be able to understand that, like, this patch has this much of forest, we have to increase the area this much. This area has the 10% of only crops, so crop zone, so you can increase or decrease it. Based on that, you will be able to make decisions. Then another thing is crop area estimation. You can also understand this crop area estimation. I will talk about this in later slides. Now, using the satellites, what you can do is you will be able to, I guess the farmers will be able to save on crop loss. And that we have seen is around 10 to 35% they can save on the crop losses. They can save on the farm inputs as well, because if you know the patches where actually something is going wrong, you need not to spread those fertilizer or insecticides in each and every location of the farm. You just have to sprinkle it on those locations where actually something is wrong. So this will save your farm inputs cost. We have also seen in reduction in survey time. So around 95% reduction in survey time we have seen. So what I mean by the reduction in survey time is like we have a company, we have a client who is very big client, and they have like lakhs of acres of area under cultivation. So they have a survey team which was going to every location and checking the condition of each and every plantations. So it was taking a huge time, and also more labor was involved. But using the satellite, what we can do is we will just check the locations where actually something is going wrong. We will check the crop health, the irrigation, that are out of this 1,000 locations, 100 or 150 or 200 or 500 needs immediate action. So you just now have to send your team, the ground team, to only those patches where actually something is going wrong. You can prioritize it. So based on that, you will reduce the reduction time. And our one of our client is using it, and they have reduced this by this percentage. So it is very helpful in these scenarios as well. Then I will talk about the process of our solution, like how you can do it. Like when we are talking about satellite, so people might think that it might be a very complicated thing to add the farms and get this data. No, it's not that complicated. It's very easy. What you need to do is you have to first submit the farms on the application. So what I mean by submit the farms, you need to do the geotagging. You need to provide the boundary of your farms, because when satellite visit will happen, we will be able to give you the data of that particular patch. So you can easily add the farm on our application. Then within 10 to 5 minutes, 5 to 10 minutes, satellite data will be generated. A report will be generated, which will be shared with you on your WhatsApp, on your email address, and you will be able to see that on your mobile application or web application as well. So it will tell you what was the latest satellite visit which happened on that farm. And every 3 to 5 days, this visit happens. So it depends on the location to location. But we have seen generally the frequency is between 3 to 5 days. So within 3 to 5 days, you will keep receiving the satellite data. After that, the report is generated. As I mentioned, it is sent automatically. So this report generation is happening automatically, and it tells you about the patches where crop health is declining, where irrigation is not optimum. So it will help you to understand these locations. It also have the weather capabilities. So you will get to know about the weather condition right now, as well as the forecast weather data. Then what you have to do is you have to go and inspect the farm. You have to check which are the locations which are underperforming. And based on that, you have to provide the necessary, you have to take the necessary actions and provide the solutions to those issues. And then this will help you to increase the yield and reduce the fertilization cost. Then, as I mentioned you, there is one more thing, crop area estimation. So crop area estimation and yield estimation, what it means is it will tell you about the particular crops area present in a certain geography. So suppose you are a government or you are a company who is into manufacturing chips. So you will be procuring potatoes from a particular area. So now you need to be sure that you will be able to get the potatoes from a particular geography only. So if you have done this crop area and yield estimation in advance, you will get to know that, yeah, this much cultivation, yeah, this much area is under cultivation for potato. So now you have the idea that you have an abundance of potato or you need to import it from somewhere else. If it is more than what you require, you can export it as well. So you can use this and make policies around it as well. This will also help governments, like certain countries, they are dependent on some other countries for import of wheat or rice or anything. So if they get this, they do this crop area estimation and yield estimation, they will get to know that their country has the right amount of wheat or rice or not. If they have, there is no need to import it. And if they have lesser, they can import it. So based on that, they can make these estimations and policies. And we have seen this data have an accuracy of around 85 to 95%. This is also an automated process. So you need not to do anything manually. Everything is done automatically. Now moving ahead with the plantation management. So satellite data does not just provide the details about a crop. You can also use it in plantation management as well. So suppose you have a large number of trees under your farm, and you have those farms under multiple locations. Now you want to count the trees. You want to understand the what's the age of the tree, because for some plantations, based on the age, you will get the yield. You want to know that how much area is under those trees. You want to understand the uprooting analysis. Suppose a few trees have been uprooted, you want to know, so that you can plant it. Because for few plantations there is a specific number which is required for, like suppose in 1 acre only 100 trees are supposed to be planted. If there are more, you have to uproot. If they are less, you have to plant. So all these analysis, if someone is doing manually, it will take a lot of time, because you have to visit each and every location, you have to count the trees, and there might be some manual errors as well. So you can bypass it. You can use the satellite data, and you will be able to estimate all these things. You will be able to get the trees estimation. You will be able to know the area. You can count the trees using the satellites, and you can understand the locations where uprooting analysis had happened. So this is how satellite can help in plantation management as well. We also have used this WhatsApp to provide satellite-based advisory to farmers, because in India, if we see, most of the farmers have not that much of understanding of applications, but they know how to use WhatsApp. So you just have to send few messages and add the farm using the WhatsApp. Within few minutes, you will receive the satellite report, and it is like very easy. It contains the image of the farm bifurcated in 9 directions. So it tells you like the Farmonaut has obtained the information of your farm, and irrigation is required in directions other than north, west, south, and crop inspection is required in directions other than north, west, south, and other directions. So it helps farmer to understand, and they can picture the image of the farm, that by directions they know what we are mentioning. So they immediately get to know, okay, these locations which they are mentioning, we have to go to those locations, check if anything is wrong or not. So this is how it is helping a very normal farmer as well, who is not that much tech savvy. Also, if we combine satellite data, weather data, uh, AI, ML, we get an AI model. So we have G1 AI. So this is used to provide the necessary information. It will tell you about the irrigation status. Like suppose the satellite visit happened today. So it will tell you for next 6 days how much irrigation needs to be done, because it is taking a lot of data, the historical weather data. It has all the crop health, irrigation data from the past, like you have submitted the farm, so all the data it has. It will have the location, it will have the weather data, so temperature, humidity, all the data it has. So it combines all this data and analyzes the farm, and based on that it provides you an advisory, like for next 6 days and this much irrigation needs to be done, what's the method of the irrigation. It also will let you know the probability of a particular disease or pest Based on that, it will provide you the solution as well. Like it will tell you about the solution on organic solutions as well as chemical solutions as well. It will also tell you about the solutions of feed. It will be able to tell you about harvesting and yield data. So when to harvest and all. So also it will tell you about NPK, zinc sulfur, how much NPK is there, how much needs to be given on an per hectare basis. What's the frequency you need to give it, like provide it to the farm. So these are the things which AI can do when we combine satellite, weather data, location and all. We combine multiple things, we perform the AI analysis. So it is very effective because it tells you about the things which are not alone doable by satellite. And it can help the farmers to a very good extent, and it will help them to increase yields, and so that an Indian farmer also can save a lot. It is a service which can be used across the globe because it's a satellite thing. So satellite can be used anywhere. So it does not have any location specific requirement. So it can be used anywhere in the world, and it can benefit anyone who wants to do the farming, and they can increase more using it. So that was all about around the satellite technology and how it can help the crop health sector and crop enhance the crop yield. Thank you. So if you have any questions, you can ask, Rajni.
Yeah. Okay. Thank you, Ashish, for the detailed presentation. Now I will take up some questions. Before that, I would like to check with the participants if they would like to ask any questions. I'll just call out the names. Mr. Kapil, if you would like to ask any question, you can unmute yourself or you can post in the chat box. Okay. Mr. Kiroj Kumar.
Hi everyone.
Yeah.
Thank you for in detail presentation. So I have a couple of questions on the yield estimation. So because it's extremely for me to understand yield estimation is a difficult task, to get the more accuracy. So what methodology we are following to estimate the yield? That is my first question. Yeah.
Okay, so for yield, we are like utilizing multiple data, because as I mentioned that we have the NDVI series of a particular crop, like it has the historical data we have. We combine that data with the weather data. We have an algorithm which matches these things, and they match the heat signatures and all. And based on that, it predicts a yield. It does not tell the exact number. It will predict that this much yield is supposed to happen if things are like this. So this is how this crop yield estimation is being done on our platform. Yeah.
So means, is there any analysis done the accuracy of the yield estimation? Means 80% or 85%?
Yes. So yeah, the accuracy which we have received from our clients only, we only rely on that number. So we have received around an accuracy of more than 90% from our clients.
Okay. So my second question is, as you know that there are different crop seeds, means we'll get different type of crop seeds. You have different yield estimation, yield outcome from different seeds, fertilizers. And if you apply the proper fertilizer and depend on the requirement of even if you see the geographically, if you go for Rajasthan, there is a yield estimation, something is different. If you come to the South India, the yield is something different. So how do we analyze this kind of mechanism? How do you know that this is a particular Rajasthan part is having some X value? Are we using any crop calendar? Or how do we estimate that?
Yeah, so as I mentioned that when we are doing this AI analysis, so each and every data is being sent to it. So it knows the location. It has the specific location of the farm, because we have this geotagged farm. So based on that, it performs the analysis and provides you the yield. It does not like just if a crop is wheat, it will tell you this much of number, because we have the location, we have the weather data, we have the NDVI, NDMI, all the series. So it combines all those data and provide you a approximate number on that. So we have
Okay.
all algorithms on the background which are running, because we have did a lot of research, we have a lot of data. So based on that, it works. Yeah.
So
Alone
are
it.
we using, are we using satellite weather data, or is there any real-time weather station
So actually,
data?
yeah. So the weather data is based on the like stations which are nearby to that particular farm. They are not been taken from the satellite.
Okay. So means it's from IMD, we can say that. Yeah.
Not IoT, because third party, there are like a lot of companies who provide this data. They have their sensors installed, like weather stations installed. So we capture the data from them.
Okay. Thank you, Ashish. Thank you so much.
Thank you. Yeah, Rajni, anyone else?
Yeah.
You...
Sorry. Okay. I think there was some disconnection.
Okay, okay. No issue.
Yeah. Mr. Naveen, if you have any question, you can. Yeah.
Yeah, I have one question. Like, do you currently working in like insurance company with an insurance company for agriculture insurance related activity, like yield
Correct.
prediction or something else?
Yeah, sure, sure. Yes, we are working with a company. I don't have much details, but yeah, we have a platform which we are providing to a bank. Using that, they are able to fetch the data of that particular farm. Suppose a farmer comes to a bank and he asks for a loan or an insurance. So how bank will
Mhm.
know that how much insurance we needs to give him? Like if he is lying or if he's saying the correct, like it's his farm, and how was the cultivation on that farm. So based on that,
Okay.
we'll be able to decide, like if a particular farmer comes and he says that this is his land, they can actually match it with the taluka level data, with the survey
Mhm.
number, and based on that they can also check the satellite data. So they will get to know that a particular farm has a particular crop, and it has performed good in past. So based on that, they can give them crop loan or insurance. I don't have the much details, but yeah, we will definitely add it in our website soon, so that each and everyone will have the correct
Mhm.
full information about it. Yeah, but we are working with a company on that same.
Okay. Okay. Thanks. Thank you very much.
Thank you.
Okay. Shishmita Swami.
Yes, good afternoon. It was a very nice informative webinar. So I have few doubts like does the solution also have a pest and disease forewarning where a user can know which are the like predicted pest and disease which could be infested to the crop?
Right, right. So yes, as I mentioned, we have now we haven't created a G1 AI. So this AI system gives the prediction.
Okay.
Suppose there is a plantation, so it will tell you that this plantation might have this pest or disease, and based on that, it will tell you about the solutions as well. Like for organic solution and chemical solution, both the solutions are provided with that.
Okay. And based on the weather data, can there be any advisory where a, a farmer can be told, depending on the wind speed or direction, to take up his spraying activity?
That I guess right now is not incorporated, but thanks for the feedback. What we can do is we can incorporate this thing as well. Right now, what we do is we can tell about the irrigation status, like for 6-7 days, because we have the forecast weather data. So it
Okay.
combines that and tells like how much irrigation needs to be done on next 5 days or 6 days or 7 days.
Okay.
Yeah, but
Uh,
using this
yeah.
wind speed, yeah, we can actually add this as well.
So there will be a forecast of probable wind speed for future
Yes,
few
yes.
days, suppose 3 to 5 days.
Yes, we can add that because we have the data, we can definitely add it. It is highly customizable because as we come up with solution, we get feedback and we customize it accordingly.
Okay. Is there any feature where if a user uploads infested image of his crop and AML kind of model which detects which pest or disease it is?
We actually had that, but right now we have removed that feature, but it can be easily incorporated. But using this AI, I don't think there will be any need for image, because it also needs to be captured with a good camera and all. Then the resolution comes in, and it will increase the data also, like the data size will be increased of the application. So you just have to add the farm and subscribe to our AI services, and it will tell you about this pest and all. And then you can get it checked.
Oh, it's like a consultancy service.
You can say consultancy, but it will tell you about that data. So yeah, you can, it will, suppose you have a farm, you now just have added the farm and you have
Okay.
subscribed to our AI. It will tell you these details, like when needs to be, when you need to irrigate, how much irrigation needs to be, and what's the pest. If that pest is there, what's the solution? It will tell you
Okay.
solutions and all. So it is an UI feature which you can see on your mobile application and web application both.
Okay, Ashish, thank you.
Thank you.
Okay.
Okay, so one second. Yeah. Okay. So most of few questions are basic. I think you already answered. What is a satellite-based crop health monitoring system?
So it's a system which mainly utilizes satellite data to provide crop advisories. So we are utilizing satellite, which is like available, and they provide this raw data. We get that raw data, we convert it into meaningful information, and we then showcase it to our users in a very easy manner, so that they don't get confused like what they need to do with data. We have our web app platform, we have our mobile applications both on Android and iOS. You will get a color coded image as well. So suppose how will you know like which locations are in bad zone, which locations are in good zone on a particular farm? So we have color coded it. Each and every our index have this color coding. So it's green to red. The more the green part is there, that means the crop is in good zone. It may be the irrigation status, it may be the crop health. So it will tell you that which area is in good zone, which is in medium zone, and which is in bad zone. So the more the it is on the red side, that means there is something wrong on that particular location. So using this satellite, we provide these all kind of things. Then also it comes, there is like crop area estimation, crop yield estimation, tree age estimation, tree count, and tree uprooting analysis. So there are like multiple things which you can do using the satellite. And also there is a positive to it, because most of the things, if there is a hardware needs to be installed on a farm, then you have to maintain it as well, because you have to check it every day. Someone has stolen it or not, is it present there or not. And also there, then it comes to like you can't install it everywhere, but using the satellite you have an access to the whole globe. So the service is available everywhere in the world. You just have to change few of the things, because each and every location is different from other. So based on that it requires few tweakings and the data is ready. So this is what satellite based crop health monitoring actually means. So we are utilizing satellite data and providing crop health and crop irrigation advisories to the farmers and businesses and organizations.
Okay. And how does the satellite-based crop health monitoring system help farmers?
Yeah, so it helps farmers in like multiple ways, because if you speak about farmers, they don't utilize technology that much, especially in India. They know there is a technology, but they don't know much about it. So they rely on traditional methods only. So when they see there is a pest infestation, what they do is they provide fertilizer or insecticides on all the farm they have. When they see there is a particular patch having less soil moisture, they irrigate the full farm. So instead of that, if you have the correct knowledge, like which are the patches which actually require irrigation, and which are the patches which actually require crop this insecticides or pesticides. They just have to apply it to those locations only. So instead of applying it to a full farm of 1 hectare, you just have to like now apply on the 25% of that farm. So now you have like saved on that as well. You have saved on fertilizer input, you have saved on water, like for the irrigation. So this is how you do it. And when you provide excessive fertilization, then it also harms the soil quality as well. So now you have like saved all the three. And if you have saved on all the three, then you will get a good yield as well, a good quality yield. So if they perform this analysis on a good manner, then they will be able to save on all these 3 to 4 areas. So this is how it will help farmers, and they need not to like keep visiting the farm every day, because the satellite visit happens every 3 to 5 days. So based on that frequency, if they see there is a good bad patch, then they only need to go to that farm. Otherwise, they can just be at their home and seeing the data. So
Okay.
this also helps them in that as well.
Okay. What type of satellites are typically used for monitoring crop health?
So actually, there are multiple satellites which are being used worldwide. So you can use the satellites from ISRO. We have European Space Agency. We have Planet Labs. So there are like multiple satellite data providers. So we have to like subscribe to their programs, and then we can receive that raw data, and then we can convert it and showcase to our end users. So they are like Landsat, and there are like multiple names. I'm not recalling the names of the satellite, but there are like Sentinel-1, Sentinel-2. So these are the satellites which basically provide this data.
What kind of data do these satellites collect to monitor crop health?
So for crop health, there are like multiple data, like normalized difference vegetation index data, normalized difference edge index data. So these are the indices, and there are like particular sensors on the satellites. These provides the data about crop health on normal days, but when there is a cloudy weather or a rainy season, these sensors are unable to penetrate. So few satellites have this microwave sensors. So microwaves are able to penetrate even in cloudy conditions as well. So in those conditions, radar vegetation index is used for crop health.
Okay.
Yeah.
And how is the data collected from satellites analyzed to
So actually,
determine?
yeah, so the data is actually with these companies which I mentioned you. These are the providers of satellite data, and they provide that data as in raw format. So they are just a very raw data. If you will see it, you won't be able to understand it just by looking at the data. So we have to analyze the data and make it human readable. So this is how like this works. So they get this data from their satellites, and then they provide it to us.
And can satellite-based crop health monitoring systems detect pests or diseases in crops?
Yes. So to be very frank, just using the satellites only won't be able to tell you this pest and insects data or disease data, because the resolution which is available in a very what we say a good manner, like is 10-meter data, 10-meter resolution. So this is this is very affordable. Otherwise, if we go to a very high resolution data like 3 meter, 1 meter, and centimeters, then the cost increases very much. Then it won't be affordable for like farmers. So the 10-meter resolution data, if we use this, we won't be about to tell the pest and disease data just using the satellite. So that's why we are using AI here, because it takes into account the satellite data, the weather data, the location, So combining all these will only be able to tell or predict a particular disease and all.
Okay.
Yeah.
And how often are satellite images typically updated for crop health monitoring?
Yes. So the constellation which we are using generally like covers a particular area again in 3 to 5 days. So the frequency is 3 to 5 days. In few locations, it might be happening in every 3 days, few 4 and few 5. So it totally depends on your location. But the major frequency which we use is 3 to 5 days. There are satellites available for single day as well, like every day it will do. But again, the cost comes into picture and it becomes more costly, and then it won't be viable for a very like marginal farmer. Big companies can use them, but they also need to have a very large scale to go to make it feasible for them, affordable for.
Okay. And what are some challenges associated with satellite-based crop health monitoring systems?
So there are not much challenges, but as I mentioned that just alone this satellite data with 10-meter resolution won't be able to predict about the pest and disease. So you need to combine multiple things. So first is like you need to have multiple data to get this details to the end user. Again, that then you need to have a lot of data also. Just by one satellite visit and one weather data, you won't be able to predict it. So this is one you can say challenge, because we need to have a good data of a particular farm, then it will work in a good manner. Then again, this only the microwave sensors will be able to tell you about the crop health and irrigation status in cloudy weather. Other parameters like SOC, soil organic carbon, digital elevation model, these are not available when there is a cloud cover and a rainy season is happening. So this is also a challenge, because you will be able to get the detail about the crop health and irrigation only when there is a cloud cover. Another challenge is like in India, basically, or across the globe also, we have seen that when we say about satellite, the people mainly know it about as a GPS technology, which they can use to track. So there is a less knowledge out there. People are not much aware that satellite can be used in these cases as well. So when someone tells about that satellite can do, so they are not that much knowledgeable, so they don't understand that okay, this will work or not. So they have the questions on the accuracy, it will be that accurate or not. So these are few challenges which comes when we talk about the satellite based monitoring.
Okay. Yeah. Are there any limitations to the types of crops that can be monitored using satellite technology?
There is one limitation, like the crops which are grown under any shed won't be able to we will not be able to monitor them, because satellite requires a clear view of a particular crop. So if there is any crop which is being grown under any shed, so we won't be able to track them. So this is just the limitation. Otherwise, all the other crops are doable using the satellite.
Okay.
Yes.
And now we have the last question. What advancements are being made in satellite technology for better crop health monitoring?
So so advancement is being done, like the resolutions are being made more cheaper. So if we get the resolution in a cheaper manner, like high resolution data, like 3 meter, 2 meter, so it will definitely increase the accuracy. It won't increase it much, but still it will help in this pest and disease identification. So these are being done because the more the satellites are there, the resolution and the frequency will increase. So the more the frequency, there are few crops, they require very high frequency data, because if there is a sudden change and we inform them like in 5 days, so it won't be beneficial for them. So few crops require data every day. So if there are like satellites which are being like flown to space, and once there are like good number of satellites there, so the frequency will increase and the cost might get reduced. So there are like companies who are trying to get it on the space. They are installing more and more sensors. So the more the sensors we have, more accurate sensors we have, more radar sensors we have, so there will be like less limitations, and more frequent data and more accurate data will be provided to the end users. So this will help them. Yeah, so there are companies who are doing this, but definitely it will take some time, because in past 10 years we have seen a lot of things have changed. If we think about the satellite technology being used as crop health monitoring, like 10 years past, then it won't be like that good, but now it is doing, and the companies are doing great. So there are companies who are doing this. They are making more sensors, they are providing more satellites, and using them, the technology will definitely evolve and have more accuracy.
Okay. Okay, Mr. Ashish, I don't see any more questions.
Okay.
So before we end, I think Shishmita has some questions.
Yeah. So
Yeah.
I wanted to know, what are those soil parameters captured? I heard NPK, zinc, and sulfur, and soil organic carbon.
Yeah.
What are the other parameters covered?
So right now, soil organic carbon is being done using satellite only, but other like NPK, zinc, and sulfur, these we are predicting using our AI model. So right now, these 5 parameters are being predicted, but as the technology will improve, as we get the more data, we get the more feedback, we will definitely increase more parameters, which are like very much useful to the farmers. Because what we have seen till now is like NPK and zinc and silver are the major nutrients which are required by the farmers. So we have incorporated this as of now. But in coming days, coming in near future, we will definitely increase them if we get some feedback and if there is a requirement from the farmers or organizations.
So the AI predicts these nutrients based on soil organic carbon content, or what is the logic?
Yeah, it takes into account all the things. So it has the NDVI series as well. So how
Okay.
the crop health was in particular time duration, how the irrigation was done, what's the weather, because these all things will change the nutrient composition. So based on that, it predicts the value.
Okay, there is no pH and salinity monitoring happening.
pH, sorry, like forgot this. pH is also there, not the
Okay.
salinity as of now, but pH is being predicted using it.
Okay, Ashish, thank you.
Thanks, Rishmita.
Okay. Okay, Mr. Ashish, before we end, one last question.
Yes, yes.
Please let us know little about your career background and what made you to take an interest in this particular subject, and especially agriculture field.
Yeah, so my background will be in computer science. I have done my graduation in it. And then I worked in few companies related to web development and all. Then I get in touch with Ankur. So I was contacted by him. Then he told me that he is working on this, and this is the application we are planning to help the farmers in India as well. So it intrigued me, because my father and my grandfather, they have done farming a bit. My grandfather was basically a farmer, so I have seen the condition of the farmers in India, how they suffer, and they don't know much about the technology. So most of the people's living in city, they know about the technology, and the farmers, they don't know much. So I just wanted to contribute in it, and I also like to like do some problem solvings and all. So it was very you can say challenging, as well as it was very exciting. to do something in that sector, so that I might contribute a bit. We as a company, we can contribute as a bit towards the betterment of the farmers. So this is how it came into picture.
Okay, and this your company name Farmonaut.
Farmonaut.
How did you arrive at this name?
So yeah, so it was basically decided by our founder and co-founder, Ankur and Akash Omar. So Farmonaut is basically, as you say, astronaut. So Farmonaut
Okay.
is derived from that term.
Acha. Okay.
Yes, yes.
Okay, nice. Okay.
Thank
Okay,
you.
Mr. Ashish. So now we have come to end of question round. On behalf of agricultureinformation.com, I'd like to thank you for the detailed presentation, answering all the questions in depth. And I also like to thank all the participants for asking the questions and joining the meeting. I also like to thank our editorial team for sharing the questions. The meeting will now be closed. Have a good evening.
Thank you, Rajni. Thank you, everyone.
You're most welcome. Thank
Have a
you.
great day. Thank you.
Thank you all.